This is second in the discussion series. IAMS is the International Association of Meteorology and Atmospheric Science. ICTM is the new commission under formulation with the International Commission on Tropical Meteorology, and IATM is the Indian Institute of Tropical Meteorology. So IAMS and ICTM to conduct a series of panel discussion focused on recent advances in tropical meteorology towards framing its future directions. So to briefly outline the objective of ICTM and this panel discussion, I invite Dr. Tara Prabhakaran, Project Director at IATM and a lead member of ICTM.
Yeah, good evening, good morning to everyone who is attending. I just want to mention that this International Commission on Tropical Meteorology, it is being formed under the IAMS, and it is proposed to be formed under in the an assembly, IAMS assembly that is going to take place in Baku in July. And the main theme of this commission is, as you understand, there are no tropical meteorology commission. Also, there are polar and other commissions already existing. But this particular commission will address organizing thematic conferences, workshops, and symposia. And also, it will enhance the understanding of tropical circulation systems using observations and models. And it will also stimulate exchange of scientific ideas, bring collaborations, international as well as national collaborations in tropical meteorology, and to facilitate support for students and scientists to attend such relevant conferences. The idea is to establish a strong work group and committees and joint research on the themes of the commission of this IUGG. To organize joint meetings, IUGG, IAMS commissions during major international conferences also is a theme. So eventually all of these activities will be reported to IAMS. And so I am very grateful that we have 3 pillars of tropical meteorology research joining us today to enlighten us on this. This is the second tropical meteorology ICTM panel discussion that is taking place. So I'm very grateful to all 3 of them, and let us hear from Sabin about them. Thank you.
Yeah. So as she mentioned, so today's panel discussion centers on a vibrant topic, the influence of remote forcing versus regional processes on monsoon variability and predictability. To lead this discussion, we have 3 distinguished scholars in the field of atmosphere, ocean, climate sciences, renowned for their work on global and regional monsoons, monsoon predictability, and climate modeling and climate change. It is with great honor that I introduce today's panelist, Professor Bin Wang from the International Pacific Research Center, popularly known as IPRC, and he is a professor at the School of Ocean, Earth Science and Technology, University of Hawaii. And we have distinguished Professor Padma Shri Jagadish Shukla from George Mason University, USA. And we have today with us Dr. R. Krishnan, former director of Indian Institute of Tropical Meteorology. And as moderator, myself, Dr. Sabin, a climate modeler and a climate change researcher from IATM. Along with me, Dr. Smriti Gupta. She's a scientist at IATM working on greenhouse gas observation, modeling, and carbon cycle. We will be moderating today's session.
Good evening and good morning. Without any further ado, let's come to the discussion points. And to frame the actionable points for ICTM, I request the panelists to share their initial thoughts on the theme, the influence of remote forcing versus regional processes on monsoon variability and predictability. I request each panelist to provide their views in about 10 minutes during the initial discussion round. And let us first hear from Professor Bin Wang. Sir, please.
Oh, okay. This is just a personal view. May not be really good, but I want to talk about my biased view. The regional monsoon, for example, Indian monsoon, I think the largest external forcing or remote forcing is still ENSO. ENSO as a primary source of predictability. If you look at 100 years of data, the Indian monsoon, July, August, September, October has a better correlation with the monsoon. June may be slightly less correlated. So anyway, this is the big external forcing. I think it still is the major source of predictability. The problem is that the ENSO change all the time, especially in the last 40 years. After 1970s, more Central Pacific El Nino and Super El Nino occurred. And in the last 25 years, much more multi-year La Nina occurred. And those has not been happening in the last 120 years. So the evolving nature of this ENSO brings a lot of fundamental challenge for us to look at the monsoon response. So in my view, that the non-stationarity of the ENSO property is a big challenge for monsoon studies. Of course, there are other processes. Indian Ocean dipole is very important for Indian monsoon. You can see this is remote forcing, or IC is basically the South Asian monsoon system, very close, right? And from the large scale point of view, El Nino development, El Nino decay in the summertime, and IOD, probably the major remote forcing controls large scale variability in the monsoon regions. Now, there are other secondary source of predictabilities in the regional scale. Of course, for example, there's land-atmosphere interactions, but that has to combine with large-scale air-sea interaction together, because large-scale air-sea interaction or remote forcing can control atmosphere circulation. Atmosphere circulation can generate land surface anomalies, either affect the soil moisture or other quantities, and that can remember this memory and the feedback. But this process normally only occur probably within 2 months, 1 or 2 months. And the intra-season time scale is important, but as time going, it becomes less important. We know that, all right? So, so the modeling, I think in the model aspect, the large scale land atmosphere interaction is quite important, but because both observations and the model parameterizations are not accurate enough, so that still is an aspect need to be improved. Also, in terms of the model point of view, the mesoscale convective system, if the model does not have very good resolution, is hard to capture, even diurnal cycle. And especially the local convections without high resolutions is very difficult. Those are some of the regional topography, of course, it's very important. And those has to deal with the high resolution model or embedded regional model to resolve those processes. Those processes can feed back to the local scale monsoon variability very significantly. In terms of the model, I'm not a modeler, but in general, I feel that, for example, aerosol, the cloud physics in the model simulation still has a lot of room to improve, right? The aerosol effect, cloud physics. So those are very closely related to the local processes, emission of the aerosol and so on and so forth. So there is Of course, in terms of remote forcing, recent years, you see that the people argue from southern annual mode can affect the southern Indian Ocean SST or equatorial SST. Cross-equatorial flow may affect the monsoons, and the Arctic CIS variability or Eurasian land surface, but the snow cover in the global warming situation, it becomes weaker and weaker. So the mid-latitude effect is spread to the tropics, mainly I think in the East Asia monsoon regions is quite important. I don't know how much they can penetrate into the India monsoon regions. Of course, Tibetan Plateau itself is very close to the South Asian monsoon, and some of the land surface process there, in terms of the model simulations, predictions, this is quite important. But overall, I feel that India monsoon prediction is still a very challenging task. We have been trying to do that a few years ago. Use this almost 120 years of data, try to identify a few of the remote factors. But recent years, it turns out it's not very effective, because any of the predictor you identified, they change all the time. So that is a big problem, big problem. So let me summarize. I still think the remote forcing from Pacific or equatorial Indian Ocean is dominant, and those are more predictable. But the difficulty is the ENSO prediction itself has been more challenged, right? And local process, of course, incorrect. I don't know whether this is a fitting this theme or not. I hope that is useful. Thank you very much. Yeah.
Thank you, Professor Wang, for your insightful your points. And now I turn to Professor Shukla for his initial thoughts on the discussion topic. Sir, please.
Okay, I have nothing to say. Bing has said everything. It's hard. No, he was a very comprehensive description of our state of science. There are a few things I'll add. Some of them are based on some very recent work that we, Krishna and I, are doing. I think I presented part of it in the last meeting. So I used to have exactly the same notion that ENSO is the most important thing. What we have found after looking at 120 years, it's just the observations, that if you can objectively separate the ENSO forced response in the monsoon versus the Indian Ocean forced response, think of it in terms of IoT, it's quite amazing how important the Pacific is. And I'll tell you why it is so important. Number one, all this confusion about year-to-year variability is because the Indian Ocean IOD part of the response has completely gone a big change because of global warming. So if you look at the relationship between the IOD for 120 years, you just see a different sign. And once you combine both of them, these two, by the way, I was referring to like MSSA, you get two patterns. If you use these two patterns, one for the Indian Ocean, another for the ENSO, they explain the correlation with Indian monsoon rainfall for 120 years is 0.8. I have not seen many such correlations in the observed data. And anyway, so we tried to write a paper for Science, it was rejected. So let me tell you. So we are now writing the proper paper for journal. But that was one point I wanted to you is that particularly the multi-decadal changes in the monsoon and its relationship of the IOD and ENSO is both together have to be considered. It's quite interesting. If you take any one of them, it doesn't work as well, but only when you take both of them. That needs some kind of a understanding. However, at the same time, ENSO itself has become kind of strange. That's the word I will use rather than, okay. None of the models are able to actually improve the ENSO prediction. Look at the NMME results from US. And what do you find? This paper was published just a few years ago. The skill in the Eastern Pacific, the skill of SST has gone down in the last 10 years. It's just it just be quite shocking. It's not publicized. I have made that one of the points. So now we have many theories. Maybe it has to do with global warming. Maybe it has to do with the systematic error. Maybe, but you know, when you don't know what it is, we just say it's natural variability, which is okay. That's what the guys say. So this is something that ENSO itself. And the second challenge is that you can predict Nino 3.4 very well, but the Indian monsoon response is not predictable as much. So that's another big research topic. And there are at least good example of 1997. There are other examples. So this idea that the boundary conditions affect, you know, I mean, this is how we started this conversation. And we now know that if you prescribe those boundary conditions, it's not going to help you. In fact, it's going to hurt you. So therefore, we needed a couple models, and a couple models have come, and they are beginning to show. But these are the now special questions. So what it really means is that not only that you have to predict the ocean SST Nino 3.4, but you also have to predict the response. Because as you know, once you get SST anomaly, it produces a heat source. But how does that response propagate through the medium? So there is so I think that this joint effect of Indian Ocean and Pacific is something that we are finding we need to pay attention to. And particularly if you are interested in the explaining the decadal variability and its clear signal of the global warming. Not in the ENSO, well, ENSO there is also some signal, but it's confusing. But the big signal is in the IOD relationship with the monsoon. There was one point I wanted to mention. When it comes to local, I mean, there are many ways to define local. But let's say if we define local by fluctuations based on local instabilities. So there are two comes to mind right away, right? One is monsoon depressions, low pressure areas, and the other one is the active and break cycle. Now, it's a quite interesting correlation between the phases of the active and break cycle and monsoon depression formations. Synoptically, you can understand all the maximum monsoon depressions are when the active break cycle has a trough near this. So synoptically, we can relate. But that doesn't answer the question. Is that so because monsoon depressions cause that? Or is that so because the active and break cycle is an independent dynamical entity and that creates the large scale forcing where the monsoon depression will form and propagate? I think this is a basic question in the local fluctuation that we have not been able to answer. We have a lot of data, and we do a lot of compositing of active and break cycles. And Krishnamurti and I have published a paper which doesn't seem to be appealing to most of the scientists because our conclusion was that the active and break cycle are the instabilities of the mean flow. Instabilities that we don't know very well exactly. They have a very fixed life cycle. They have a very good structure. They propagate northwards and so on. So we don't have really a good theory for their part. There are a lot of papers. Bin has written some very nice, interesting papers. But what we find is that they are irrespective of whether it's ENSO or La Nina or they're always there. Every year they're always there. And therefore, their frequency, we need to understand their role in defining our seasonal mean. So that brings the question of we really need to extend the limit beyond 7 days, 10 days to this. And there is a lot of progress being made in this, but it's not very clear. You see, the whole world is working on MJO. By the way, this week, I'm supposed to be attending a MJO predictability workshop. I just told them I'm not free today, but it was going on yesterday to today. And there is like in Banff, they're going on. I really think that we really need a similar really research effort to predict the active and break cycle, to predict the monsoon depressants. I mean, by the way, some people claim that active and break cycles are nothing but MJOs during summer. Okay, all right, well, that's the two. But some people say, no, they are combined during the right. I mean, they had some ideas that how the sort of, you can see that eastward propagation and northward propagation together. So, I mean, these are all open questions about the local, okay? But one thing I will mention that for local, land is very important. And we already mentioned about land. It is true that global warming has now overwhelmed the snow signal so much because there is a snow is just going down, okay? So it's very hard. But it's still land and initial conditions of soil moisture remain a very important factor, and it's a challenge now because our land models are not good enough to initialize the land so well that, and so therefore the demonstration of enhanced predictability because of land, which we have done very well with SST and so on and so on, is still we are waiting for that, although there is a lot of evidence that it will happen. So, I mean, the thing is that in a conversation like that, it's so easy to jump from one thing to the other, which is what I'm doing. I'm going from regional to local. But as the ideas are coming, I'm just telling you. So now, in the so far as the local 10-day forecast is concerned, we definitely need much higher resolution models and so on. But I have to say, and I had to argue with the group in IITM when I came in last year. We can't ignore machine learning. And now, okay, for 10-day forecast, we really have to pay full attention to this because it is going to be hard to beat the machine learning forecast up to 10 days. And we just have to develop our own large language model. We have to develop our own training data set based on India's vast amount of data that is available, over the station data, over the satellite data. So I think that you should definitely do that locally. Now, as I'm making my notes, I'm jumping now to the large scale. ENSO, coming back to ENSO, just I've been at this point, but I would like to emphasize this. Do you know the predictability of different phases of ENSO is different, especially its impacts. So you go to the peak phase, and now you're going to the decaying phase. The predictability of decaying phase is different than the predictability of the growth phase. And also the impacts are very different. So that's another thing that even in ENSO, we really need to really understand. The question whether the limits of ENSO predictability are because of the ocean modeling or the boundary layer deficiency or the interaction, still it is a hard topic. And ultimately, we have to pay attention to both. So let's see. Did I cover everything I had thought in 10 minutes? And I don't know how many minutes I've taken. So I was told you are very tough coordinator. So you stop me if you think I'm taking too long. Okay. All these things we hear about, Arctic, QBO. Some people have used stratosphere. But there are so many papers have been written, on this, and they always go into the list of possible factors, which are affecting monsoon. We do need to investigate them systematically and see the. So I think that I'll still leave with the first question that I asked, because I have never been able to address that, and it really requires a pretty solid work in modeling and theoretical work. That can we give a sort of a dynamical instability theory for active and break cycles? Because their property shows that they are ubiquitous. It doesn't matter, and it has been a distraction to say, oh, they are increasing the rainfall or decreasing the rainfall. That's because we don't remove the ENSO effect in the data before. You remove the ENSO effect, remove the seasonal mean, and now all the La Nina and El Nino effects are, and now look at the remaining data. It's perfect intra-seasonal active and break cycle. Okay, it is still there. And all the El Nino, La Nina does is modulates that, because you can take a sine curve and you add a mean value, you can see that it will expand the days of active and reduce the days of break. So I really think that's a fundamental question. We need to really challenge our young theoreticians to find out, because if it is true what we are saying, that they are actually fundamental instabilities, then we can study them separately from the study of other processes of the effect of ENSO, effect of land, and effect of other forcing functions. All right, I really think that I have covered most of the points that I wanted to cover in 10 minutes, but I can respond more if the questions.
Yes. Thank you, Professor Shukla, for pinpointing some of the challenges that we'll keep on discussing in this course of meeting today. And now I request Dr. Krishnan to share his perspective on this topic. Dr. Krishnan, please.
Yeah. First of all, thank you, Dr. Tara, Sabin, and Smriti for this opportunity. I think, first of all, I'm very happy, and it's a great honor for me to be in this panel with giants like Professor Shukla and Wang. And they've already made some very important points about the monsoon variability, what are the drivers, what are the large-scale teleconnections, and how they've been changing. So they covered also the remote forcings as well as the regional forcings and the predictability. See, one thing that we are seeing is the monsoon seasonal changes in the monsoon precipitation we are seeing in recent times is dominated by extreme events. So I wanted to touch on extreme, very heavy precipitation events or very dry conditions in some parts. So the extremes are becoming very common. This is what we are seeing. And it turns out, for example, 2019 and this year, for example, we already started, the monsoon onset has already taken place over India, almost 15-20 days ahead of its normal. And right now, as I see through my window, it's raining heavily and last 2-3 days. So rain for extremes are becoming very, very prominent. So I just wanted to touch upon the extremes, which are also influenced by remote drivers, teleconnections, and also by the local processes. So I just wanted to touch upon this. For example, the famous notorious floods in the upper Indus Basin in 2022, Pakistan and India, many places were very badly affected by heavy rainfall and flooding. They happened in a sequence, series of rainfall spells during the monsoon season. And at the same time, when you go towards China, the Yangtze River Valley of China was having a prolonged drought and heat wave conditions. And so on the one hand of the monsoon, western end of the South Asian monsoon.
Tara, I need to take a small break. I have to go and get some water, okay? Please, just give me keep going, Krishna. I'll be back.
Yeah. And then on the other end, when you go towards the Yangtze Valley of China, where the Mayu Bayou system is there, the East Asian monsoon. So that is very dry. And now it turns out that why these very complex extremes are happening. I think a series of papers came out in the recent times. They are telling that there was a very strong La Nina it was actually triple dip La Nina, right? We had from 2020, 2021, and 2022, and very strong east-west sea surface temperature gradient in the Pacific. And people are telling this was one of the important drivers, this sea surface temperature pattern between the warm SST in the Western Pacific and cooling in the Central and Eastern Pacific. This SST gradient is very, very important in driving these atmospheric circulation patterns. And in addition, there were some changes in the subtropical westerlies and the mid-latitude circulation patterns. They kind of were responsible for producing these very extreme events over the extreme precipitation events or western part of South Asia and also over the eastern part of the Asian region, the East Asian monsoon. So there are large-scale drivers involved. And when it comes to the local preconditioning effects, once you have excessive rainfall, the soil gets saturated. And so when heavy precipitation happens, it also is a reason for flooding. And we are also seeing with the extreme, very high temperatures in the Asian region, the Himalayas are, the temperature records in the Tibetan Plateau, Himalayan region, they're all increasing at a very fast rate. And the pre-monsoon temperatures over many places in western part of South Asia were very high, they had crossed 50 degrees. So the very high pre-monsoon temperatures, you have the melting of the snow and the glaciers. And when you have these, it appears that the monsoon depressions are also intensifying in terms of the rainfall amount associated with the monsoon depressions. We saw that last year, even the year before that. So depressions are getting stronger. And one of the depressions, I think the monsoon depression went west into in the Pakistan region at that time. And so it produced heavy rainfall. And then you have the effect of the melting glaciers. So that really increases the runoff and the flooding. So when you look at extremes, they're all really getting compounded to changes that are happening because of the local preconditioning, plus the influence of remote drivers like La Nina, and even IOD events, which we have seen in some of our studies that 2019, for example, we had a very strong positive IOD in the Indian Ocean and extreme precipitation over the many very heavy rainfall over many parts of India, especially the western part of India, state of Gujarat and other places. And so these extremes are really contributing to the total season. That's what we are finding, especially in the recent times. So this raises the question that how are we going to address? So there is an interconnectedness of these events. It is not that they're happening in one place. So what is happening over the Indus Basin and what is happening over the Yangtze River Valley, there is an interconnectedness. And these large-scale teleconnection patterns like La Ninas and El Ninos, because they can, especially a very strong La Nina can shift the West Pacific subtropical high westward. And all the synoptic systems are moving westward. Depressions, monsoon depressions in the Indian region, they are producing activity on the western part of India. So there is a very strong connection between the synoptic systems and the changes in the large scale patterns, which are influenced by these phenomena like ENSO and also the IOD. So that is one of the big concerns, how to model them, how to predict them. We are seeing them. And so one thing is definitely we need a good theoretical framework to first of all understand how these extremes are behaving. A strong theory is very, very important. And the second thing is the movement of the ITCZ. The ITCZ movement, because that is what is influencing the rainfall over South Asia. And models are having problem in describing the IOD, the ITCZ and its seasonal migrations. That is going to be a key. And so these are my points. And how do we address this problem? So the extremes are becoming important. There is both the effect of the remote drivers, teleconnections, as well as the local preconditioning by the soil moisture or changes in the snow. And many things happening in the Himalayan region and also in the Tibetan plateau. Plus, I think we really don't understand much. We need to understand the processes. We have to improve the models. High resolution is one of the ways, but that is not the end. And mesoscale convection, organization of mesoscale convection. I think Professor Wang mentioned that. And actually, the rainfall that we are seeing right now is all because of the organized mesoscale convective systems. How to represent them in the model? So that is one of the key issues. And these are going to be very important for improving our early warning system. So with this, I leave it here, and maybe we can, anything comes in the subsequent discussions, I'm happy to take. Thank you.
So with this, I thank all the panelists for bringing out the fundamental problems and sharing your perspectives. Sabine, sir, you are muted. Please unmute yourself.
Yeah, now we have 3 specific points that we would like to briefly need to be enlightened from your side. So each of you can take 5 minutes for these specific questions. My first question in this section is likely can be best direct to Professor Shukla. Sir, you already mentioned the need of separating the signals from Pacific and Indian Ocean side. But along with this, we have regional land atmospheric feedbacks, which is also important when we are assessing the monsoon variability. Can you shed some light in this regards as well?
I didn't get the question, to tell you the truth.
Yeah,
Well,
I mean, you have mentioned that the importance of separating the Pacific and Indian Ocean side. So along with that, we have land atmospheric processes also something very, very important in terms of monsoon variability. So what do you think, how we will include this ocean, atmosphere, land, and all these processes together?
Oh, okay. Yeah, the part I said about the Indian Ocean and Pacific was just an observational evidence that both are very important, just if you want to use this, okay? When it comes to modeling, okay, I mean, look at the amount of emphasis we have on prediction of ENSO, linear 3. We don't talk about Indian Ocean and the Arabian Sea. And my point was that we need to actually look at our model's ability to simulate the mean and the fluctuations of the Indian Ocean also. That was because the data suggests that it's going to be important in explaining. Land, as I mentioned, that's actually for the short-term prediction, for the regional local prediction. It's very important to initialize. So I think they're not exclusive. I think that this is what we have to, because when you are doing modeling, you have a modeling group, somebody's working on land just because, why? Because you have somebody who works in land, so therefore you will continue to work on land. The thing is that there should be this organized effort to see that we try to model the components that are important. This has been a issue. So they have to be done together. There's no doubt about it. Okay. Can I take 1 minute just to mention about Krishna's point
please.
about extreme events? Krishna, we didn't touch on extreme events for a very simple reason. Let me tell you, I have a very simple. I don't do research on an extreme event, and the reason I don't do it because I found it so complicated to do research on extreme events, because what it is that we are talking, how is it different than predicting, predictability of weather? And the question is, how many days back you have to go? 10 days, 15 days, 2 weeks, when you can still, your model can capture the extreme events. There are many people are, but I always get faced with extreme events about global warming question. And I have a very simple physical argument that I find it sufficient for me. That is, we teach our students right from day 1 in dynamic meteorology classes that the weather fluctuations depend upon the mean climate, right? I mean, that's how your textbook 101 dynamic meteorology. We do first instability analysis. We show barotropic instability, baroclinic instability. Basically, we are following Chinese, who has been our guru. That's how weather happens. These are the instabilities. So the mean flow is very important in determining weather. That's, by the way, in my lectures, I have started using a slide that's called "Climate is Mother of Weather." Now, why I say that? Because it is the instabilities of the mean climate that determine weather. So now, if the mean climate is changing, the structure of the wind flow is changing, whether it's global warming or large-scale, atmospheric, decadal, planetary scales, for whatever reason, then obviously instabilities will change, the fluctuations will change. And all these dialogue and discussion about, well, this hurricane caused by global warming or this extreme event was caused by global warming is actually, everything is caused by global warming if it is different than before. So that's my view, is that because that's our basic dynamic meteorology. We may not be able to prove it, we may not be able to detect it. So I don't have a good answer to Krishna's question. It is very important, but my solution to that is that we as a community, and suppose you're having a meeting and you're saying what to do, there should be a model in comparison of individual events. So if there is one suggestion I have, which I did the same thing for seasonal prediction 20 years ago. So I'm telling you, and I think we start you start one event in somewhere else and the other person starts another event in another year. I really think that if we can understand predictability of a few events, so if there are multi-model experiments, or if the same institute has enough resources to do, go deeply into understanding that particular event, how much it was affected by initial condition, was the model good enough to get anything at all, and know what had to be done to do that for that particular event. But see, this is very difficult to do this research, I'm telling you, because you have to write a proposal, you have to gotten funding, and you can't say, hey, for 5 years, I'm studying this event in Uttarakhand. I mean, unless you have a center. But that is what is needed by in a coordinated way. Several modeling groups should attack individual events. That's where the same thing happened about ENSO, and we made a lot of progress. So that's the only suggestion I can make, Krishna, that if you want to make a progress, and if a forum where you are intercomparing are getting modelers from different countries, this will be one possible suggestion, is that can't we do actual events rather than 30 years of anomaly correlation? Everybody shows 30 years of anomaly correlation. And then, I mean, what do you come with? 10 curves. On the other hand, if everybody concentrated on understanding a few big events, maybe we'll make a progress. What happened? Sorry, I took probably more than 5 minutes.
Yeah, thanks, sir, for placing your view. And great that you are proposing like a CMIP-like activity for particular event, which we need to deeply into it. Yes, that's really great, sir.
And not exactly, but also for monsoon season. You can take one monsoon season, which behaved very strangely out of nowhere. There was a huge bit. Let every modeler try to do that and see.
Yes, sir. We will press this as one of the strongest points from this discussion. Thanks.
Yeah.
Thank you, sir.
Let me just say one thing. 2022 is really a very good example of extreme season. If you look at the West North Pacific subtropical high, it is recordedly strong in the last 40, 50 years. And that is not very predictable. So study this specific extreme years, I think can learn a lot.
Very good. Yes.
Yes, sir. So now we turn to Dr. Krishnan for the next question. Sir, as you rightly pointed out, the importance of both remote forcing and local preconditions for the predictions, better predictions. I would like to ask, given the increasing complexity of coupled models, how should we prioritize improving the representation of remote versus regional process to enhance seasonal monsoon forecast?
I think you asked a very tough question, but first of all, before I answer that, I want to just compliment what Professor Shukla said. We need to, because these events, let us say 2022, as Professor Wang was mentioning, we focus that particular year, look at the extreme events from multiple models, which should be coordinated. So I remember 87 and 88 monsoon. One was a El Nino year and one was a La Nina. I think Professor Shukla was at that time leading those efforts. Many groups did that. Focus. I mean, this is long back in the 80s and early 90s. They were just doing this 87 monsoon, 88 monsoon. Now the time has come, we really start looking at these very big events like the 2022. Because I remember even 2010 was also, we published some papers, was also a La Nina, and the floods happened in that region in 2010. But the scale of the flooding, heavy rainfall and flooding was much more when you compare the 2022. And also by that time, the temperature increase was also substantial from 2010 to 2022. So I very strongly endorse and compliment that view that we should have experiments among multiple groups focusing on these very special events, why they're happening. And that will be, we will be able to assess how good these models are performing. And the point is that it is not just related to the atmosphere or the ocean or the land. They're all interacting. So you really need a coupled framework to really address this problem. And because once the soil is getting wet and the monsoon depression goes into that region and produces rainfall, the increase, you are really going to increase the runoff from the land. Same with the melt. So what happens, melt of the snow in the month of May when high temperatures are there. So carefully designing these experiments, how are you going to design, first of all, these coordinated experiments to see the effect of how these extreme monsoon precipitation events are happening. And we have to not just focus on the western part of South Asia, also see what is happening to the Yangtze River Valley. And these are all very highly interlinked, interconnected signals, and through the atmospheric circulation changes. So developing a major international, if we can come up with a call for proposal or something, just like in the CMIP, they have a MIPS model intercomparison program. We can do a similar thing for this, focusing on dedicated events in the Asian monsoon region and improving the models. First of all, we need to understand and we need a good theoretical basis. Now, for the Indian monsoon, there is something called the convective quasi-equilibrium theory, which apparently the models are doing very well. This was proposed initially by Arkawa and Schubert, now Kerry Emanuel and group. I think they are endorsed, they're telling. That seems to work well, the representation of deep convection in models. And so unless you have a theoretical framework, how the circulation and moist processes, how they are interacting, I think that is going to be very, very important. And you need a coupled modeling framework, and we have to rigorously test these models, how good they are doing. I think that will be my suggestion. And only one we will be able to understand how these models are behaving.
Yeah. Thank you, sir. So my next question is to Professor Wang. We can get Professor Wang's view on the point, what observational strategies or field campaigns are needed to better understand the relative roles of remote and regional drivers in monsoon predictability?
Oh, this is, I really cannot provide you insightful views on that. So You mean in terms of the observations, right? Yeah. Mm.
Yes, sir.
I think, first of all, the land atmosphere interactions, the land simulation, the land impact need more observations to check the model's capacity, to improve the model's land atmosphere interaction. That is probably something very much needed, especially in the highland regions like Himalayas or Tibetan plateaus. They are very much lacking these observations. So whether our land surface model can reflect those is quite important. Another thing is that maybe in the land area, we should increase the density of the observations to or use radar satellite to try to get more accurate behavior of the mesoscale convective system, because those are heavy rain, barren system, and I think the extreme flooding events often related to those mesoscale system, and those need more intense observations to check the models, to try to improve those processes, local convections. That is what I'm thinking, that it's probably toward the more dense observations and collect more data on that aspects.
Yes, thank you, sir.
Yeah.
Now, I think ICTM wishes to receive actionable recommendations based on this.
Just a second. Can I just
yes, sir, please.
comment on the land that we just met? I just want to emphasize it's a very important point he made. And at COLA, there's a whole land group, and they have published and they're writing some more papers. The skill of improvement of the prediction, seasonal prediction particularly, was so strongly related with the density of rain gauge stations. And the reason was because the density of rain gauge stations affected the initialization of soil wetness. Because otherwise, all the soil wetness is model generated in a way, because you do that. So that's a very important point. But I have a but. You can't get these countries to suddenly enhance their network. That's a much bigger task. You can say that. Let's come to something practical that this group and this commission can do. The commission can make sure that all the regions at least share their data. You look at the Indian, say, monsoon rainfall data. Indian region is filled with this data, and then Pakistan, there is some stations there, and in Bangladesh, I tried. I think it would be a great project if this project could somehow not only recommend, but suggest steps that actually these countries, and so your goal should be to create a comprehensive land. Just let's keep it simple to the rainfall data, because that's both for land process, and there's always resistance, and India is one of the great examples of resistance. For 20 years, 25 years, India will not share its observational data. And I just got into so many arguments, and I was thrown out of so many meetings by the Indian officials. And my argument was that an Indian scientist also didn't have access to the data. And once IMD released this gridded data, just go and look at how many papers have been written. Just go and read at how much progress Indian monsoon research has done, okay? Just by Indian scientists. I'm not talking about, so this was kind of, it was just a peculiar situation where Indian monsoon research was being totally hampered by the fact that some component of India, but security reasons or whatever, I don't question, was not able to share the data even with the Indian scientists. Once it happened, the whole monsoon observation research absolutely blossomed. I'm sure you just have to simply look at your bibliography and the references. You may have to do the same kind of work with Bangladesh, with Pakistan. You may have to find local leaders who are willing to bring that data. And then finally, you have a comprehensive Southeast Asian, kind of rainfall data if you want to address this problem. This was just a suggestion. I've always think that should be made, but this was a good part because you guys were talking about observation and being made the point about the line. This is a possible suggestion. Thank you.
Yeah, thank you, sir, for pressing the need of data sharing across the various countries. And I hope we will able to take care of this under as a recommendation from the Commission as well. Now I pass to Tara Madam because ICTM wish to receive actionable recommendations based on this panel discussion. For this, I hope Dr. Tara Prabhakaran may have some couple of questions to the panelists. Over to you.
Actually, thank you very much for the enlightening discussions, touching from the very local to the regional to the large-scale aspects of monsoon and monsoon observations, predictions, and actually there are some of the aspects you mentioned, like the mesoscale convective systems and their representations in the models. Actually most of our recent studies like the GPM observations, the satellite observations, basically, they have indicated that several of these extreme events, extreme precipitation associated with the monsoons are also associated with the mesoscale convective clusters. And so the need for understanding them was very well emphasized in this particular discussion. And also the complex processes, complex linkages has been highlighted. What could we do as a commission to say, for example, we also have a discussion on the model intercomparison projects. That is a very excellent idea, and the Commission was also discussing this particular aspect. And how can we indeed do this? Like, how can we make it happen? Because there are indeed several groups working on, and there are several models out there. There are different forecast centers out there. However, there is a requirement to bring together this community to do this kind of, for example, if we want to look at that 2022 event, how can this take it forward, in your opinion? I'm just telling as an example. So what would be needed from the Commission?
Wait a minute, is there a question to whom?
Yeah, it is a question to, sir, please, Professor Shukla, please enlighten us.
Oh, sorry, I thought it was a question to Sabine and Smriti. So you were asking what should Commission can do, right?
Yeah.
Okay, I was really, all right, I'll give you a quick response. I need to think more because I don't have a clear idea of what Commission can do besides arranging and recommending meetings and conferences. But they can make recommendations out of that. But when it comes down to doing something, a letter that comes from the Commission let us say, to the heads of the weather services of many countries that, hey, we are starting this thing, and we'd like you to identify some person in your country who can contribute to this. This is, I'm just giving you a scenario that's something they can do, and they are the only one who can do. Couldn't do. Okay, a letter from like that from any one of us will not have any weight, because they have they can be the agents for implementation of your recommendations by simply, but they will need your suggestion, your draft, that, okay, here's the letter that you want to send them. The reason I'm saying that is because when I came to know that there are forums, seasonal forecasting forums, for South India, there was none one for Southeast Asia, and South Asian Seasonal Forecasting Forum. So we just thought about, let's do it, how to do it. So I had found that, by the way, if you have a meeting in India like you had in March, how many people from Pakistan came to that meeting? Maybe you or Krishna can tell us. Not, did anybody come from Pakistan? No, right? Okay. But people came from China? Yes, they came, okay. Now, I'll tell you the reason I'm saying is that our region of the whole Asian monsoon is a very complex region, not only for monsoon and topography and rainfall, but also politically, okay? So this is just, I want to throw this idea is that whenever you are planning such a conference, you should consider the possibility of having such a conference in a neutral place where all the participants can come. And that was the idea behind arranging these meetings at ICTP Trieste or some other, in Switzerland or somewhere. I mean, it is also costage involved. So just keep that in mind, because if you want to have participation of several countries, then you have to find, because these countries don't talk to each other, but they have the data. You want Pakistani data, you want Bangladesh data, you want them to meet together. The meeting I organized had like Myanmar, Pakistan, Bangladesh, Bhutan. I mean, this because they all can come. And I asked the Secretary General of WMO to write to them, and Director of ICTP to sign the letter. They all came. So I'm just saying is that our region, I'm saying our because we're all from that region, so we cannot change it. That's our destiny, that's our luck. But we have to work out systems where it can really, things function. So if you really want it to be, I mean, also there is always a desire to hold a conference in your institute because also the facilities are there. So keep this in mind, this balance. This is how they can help see that there is a participation of, all the countries that are affected by the monsoon. I know it's a little divergent, but this is a point which has been on my mind for a number of years. So I thought I want to tell you.
About the ratio. So, Professor Wang.
Oh, I want to emphasize that I think Shukla mentioned the AI. The AI is a data-based, data-driving technology. So recently, for example, in Nature has a paper called end-to-end deep machine learning predictions. In other words, in the weather forecast, they use the real analysis data to train the model. But the model has a biases. So the idea is just use observed rainfall data. For example, in India, you have a lot of rainfall data. Now, they reflect regional differences. And if you have a very good data set, they can directly use AI to do some of the forecast. So I think data sharing, how to do that internationally is very, very important. I think the data collections, collaborations, I don't know how to do that, but Shukla knows much better. There are a lot of politics involved. It's not an easy problem to solve. So although we know the collaboration, the data sharing is so important, but as an international organization, this should be a priority to consider. Okay.
I also invite Dr. Gnanashilan to his comments on this.
Yeah, thank you all the panelists for giving us a lot of insights on both the regional and the local impacts on monsoon, and the possible interaction between the teleconnections and the land processes. So it is better if the panelists come out with some written recommendations, so which we can forward it to ICTM, and we can see whether any actionable decisions are taken. And the experiments what you have suggested are very, very important, and maybe some questions like most of the climate models overpredict ENSO-monsoon relationship. Is that a big question to be addressed? And the shift in monsoon patterns, whether the main flow is really important, but then if the main flow is changing, whether the Indian Ocean warming has any big role on that. So that's also an open question. And if the monsoon depressions are moving more westward, but what is driving them? So like there are several open questions. So if the panel comes out with some strong recommendations, I think the ICTP can the ICTM can really take it up and see that it's all the actions are taken. Thank you so much for giving a lot of insights on most of the open challenging questions.
Yeah. By the way, you made a very good point about all the models over predicting ENSO. That's absolutely true. I forgot to mention particularly CFS, which is the view I use. ENSO power is high, but the correlation with IOD is zero. So this is a joint. This is the point that so you could the same model, the over predicting ENSO and absolutely not doing anything to IOD. So that's a very good point. These kind of things should be pointed out.
Yeah.
Mm-hmm.
Thank you very much. Yeah. Any more points? I think we can also invite others to.
Yeah. Do we have any questions from IITM Hub? I don't see any questions on YouTube posted so far or in the chat box. So any questions from
anyone in this room who would like to ask a question? Yeah, you can think about. So
yeah, Dr. Krishna was trying to tell something.
No, so actually, sorry, my internet got disconnected. There was some problem. Yeah, yeah. I think one of the recommendation is doing this coordinated experiments. That we have to do with coupled models. I think that is one thing, and not just the prescribed SST or something. But all the groups should have a same protocol when we do this, like the CMIP sets in terms of the forcing and everything. So all the modeling groups should do the same experiment. That will be very, very important. And also the evaluation metrics also should be same. So that is one of the recommendation.
Yeah.
What about in the sub-seasonal time scale for Indian monsoon? You think in this aspect need to do some coordinated experiment?
I think there is already some effort going on. The sub-seasonal predictions. I think ECMWF, some groups were already doing it. The forecasting and the sub-seasonal prediction of the monsoon. Different groups were participating. Yeah.
But there are no such experiments involving this mesoscale means focused on more local, like the mesoscale convective systems within the monsoon, or integrating the different data sets that you mentioned. There is no such effort going on right now in a model India comparison project, I feel.
That's right.
Yeah. Ben's suggestion about doing something about intra-seasonal, the only thing I can think of just on the top of my head, Ben, is that just like we were talking about choosing very interesting months from monsoon point of view, there are months where we have very active and break cycles, and see if our models are able to, how long actually they can capture it. And you can try to do that from, and again, you have well-defined modeling protocol and this, and you are doing, because then several people will have different modeling physics, they will have different, and then we'll get some idea about these intra-seasonal variations, or what is their predictability, at least in our current state of modeling.
Want to ask something. Recent some of the researchers show that there is more convective systems forming over the Indian region than the stratiform. So there are so what do you think about this? Actually, the convective clouds are more complex and more more chaotic than the stratiform counterpart. So maybe let me ask Professor Wang.
Oh, I think the global warming's effect increase the moisture content in the atmosphere. This makes the atmosphere more unstable, more convective stable. So the variability increase. This is pretty much have a strong consensus that with global warming, temperature increase, moisture increase, the variability increase from a short time scale like hours or days, daily, or intra-seasonal, or interannual, even decadal. They all increase across time scales. And another more confident information is that the development of the cities actually also caused the land surface change, and that change caused much more high frequency, heavy rainfall. Those are the change of the landscape or change the large scale environment. I think in the future, we expect this extreme event going to increase continuously. So therefore, this is a big challenge, a very big challenge. We should pay attention to this.
Yeah, that especially that particular topic, I feel there are some promise to do some more in-depth research in the and you also mentioned a lot about the Arctic sea ice variability. Actually, one of my colleagues, he recently went to Southern Ocean, and he was mentioning that this year there was no sea ice. He felt that there was very nearly less, and also there are some reports out there in the press regarding the very much depleted sea ice. So what do you think this indeed can have an impact on our monsoon system?
Yeah, the southern northern hemisphere contrast is a part of the large scale monsoon dynamics, especially in the longer time scale, like a decadal time scale. We talk about the AMO, the North Atlantic warming, Southern Atlantic relative cooling, but the Southern Indian cooling is also very important. So the contrast between North Atlantic, Southern Indian Ocean, this thermal contrast in the multi-decade timescale change can affect many monsoon regions, including Africa, North America, and the Indian monsoon. So the Southern Hemisphere thermal condition changes could have a longer time scale influence. This is one aspect I think as a monsoon prediction we should pay attention to. The non-linearity, the non-stationarities come from the decadal, multi-decadal variability, right? So I don't know in the shorter time scale how important is the southern annual mode or Antarctic conditions affect the Indian monsoon. But in the longer time scale, the time scale longer, the spatial scale is also larger. In that context, they could affect the shorter interannual variability. It is a part of the monsoon variability. Multi time scale interactions.
And, actually, now in India, we have a new program, a new mission named Mission Monsoon, where there is an effort to increase the observational network and also to do work towards the development of Earth system model at shorter time scales. And so the one thing that is going to happen is enhancing the observational capability of the region, especially also over the cities. You mentioned about the impact of urban areas. So we are indeed there are efforts in trying to capture some of the observations. So having collaborative, I'm not just talking about India, but in general, there are such very concentrated observational sites such as the test beds considered under and also considered under the mission monsoon. So these could indeed pave way for the physical parameterization development, physical modeling model development. So do you think that this commission can pave some way to bring together such data sets? For example, this is something that is needing not high intense observations over one location or one region. It is also needed in geographically different locations or different regions. It has to, it can indeed bring together a kind of verification or physical model testing data set. Do you think that we should make any effort towards something like that?
Yes, certainly. I know there is a regional climate center, WMO, in Singapore. Is India also a part of this regional? WMO has a different regional office.
Yeah, there is a event. I'm a part of that group. WMO, and under WMO, there is a steering group for where the urban modeling. So yeah, we are indeed under WMO. There is some effort, but we need a as you mentioned, for both the observational data, modeling, model intercomparisons, various aspects we have discussed. So what do you think? Whether we should make any effort regarding this urban scale?
As far as I know, China has a strong interest to look at Asian monsoon, Australia monsoon, and even Africa monsoon. Look at this larger Eastern Hemisphere monsoon system. Professor Renhe Zhang, Z-H-A-N-G, I think he went to India recently, attend the meetings. He is basically the leader. He's in the Fudan University. He's trying to organize many of the Chinese institutions to do, including the field experiment and ocean observations. China has a lot of problems regarding the data sharing. Even the university professors, they cannot get CMA's station data. This is a problem, as mentioned, in China as well. But I think international collaboration still is important in some sense.
Yeah, so there are a few Chinese members in the group. So we would indeed try to bring together collaborations, research collaborations on data or whatever way they can indeed share information. Is there anything else? Anybody else want to have a? Yeah, there is one question out here. You able to, or you can come here and talk, or you can talk there. You see.
So, hello all. Am I audible?
Yeah.
Yes.
Thank you so much for the wonderful insights through the panel discussion. So my question is about the active and break phases of the South Asian monsoon. So my understanding is that the predictability of a break or the synoptic variability within the active phase is a little comfortable or easier rather than the predictability towards an active phase. For example, the recent episode when the monsoon has been moving towards an active phase, the models were not able to clearly predict the synoptic variability. The models were differing in their kind of solutions, giving a random synoptic variability. So, but when it moves to an active phase or when an active to a break phase, the evolution is the predictability is good in the models. So what kind of efforts, either in observations or in the modeling, may be required to improve the physical processes understanding, especially when the monsoon is moving towards an active phase on various spatio-temporal scales? What kind of observations or modeling efforts might be needed?
That is a good question. Well, equatorial Indian Ocean is origin of those northward propagation disturbance or the rain band. So the equatorial Indian Ocean monitoring probably can give you benefit of improve this active monsoon.
Yeah.
So,
can I just comment on this question, Ben? Is that
yes, please.
No, the comment you made makes a lot of sense. This is exactly what happens when the ENSO, different phases, as been pointed out, and I told you husband, different phases have different predictability. And obviously, it makes sense because the mean conditions are different, are evolving in a different way. But the first thing to do about this will be to actually document the validity of your statement. In other words, with sufficient data, if you have it, that here is the nature of difference, because you are now talking about not just the active and break cycles, but the difference between the predictability of the active and break cycle. So you really need to document that first from the data. I think that's the general impression. I have exactly the same impression for phase dependence predictability, but it will be good to first document that. And then there are several physical processes which will come into play. For example, suppose you have a break condition, okay? You have a break condition, there is no rainfall, the land is very dry, and therefore the possibility of land contributing, anything to is very different when at the peak of the active, the land is very wet. So I mean, just the land effect can be so different, but in the middle of the active or break. Same thing about the aerosols. Okay, you have an active cycle, and suddenly all the aerosols are washed out, right? They're all washed out. Now imagine the radiative effects of the aerosols will be very different at the end of the active cycle versus the break cycle, right? Because they also affect. So I think physically what you are saying makes a lot of sense. What we really need to do is document exactly. Same thing with the I mean, there's a lot of network about the aerosols. There are a lot of, and we should be able to, I've been telling this, talking to these people in IIT Kanpur and other Aeronet network people, that, you guys should really look at in detail how the aerosol concentration is fluctuating with time as you go through active and break cycle. Because as many people have shown, Bill Lau at NASA started, and many other people have said, the radiative effects of aerosol during active and break cycle can be significant. We just have to, it's not just the mean, because it's fluctuating. So your comment makes a lot of sense, but I really think we need to document it much better.
Okay.
Actually, as the wet season, wet period ends, so there will be the sources, aerosol sources from burning and other activities also will contribute. So then there will be again a spike, and then there are documented evidence now with long-term observations. So to do this kind of studies over India.
Yeah.
So, yeah. Are there any more questions from here? You want to ask anybody? Yeah, Vijay. I think
Panelist.
Come here and talk.
Right from the room.
See.
Audible?
It's audible. Please go ahead.
Yes.
Hello, panelist. Good evening. My name is Vijay. I have actually one query from Professor Shukla. So, sir, you mentioned that if we segregate IOD and INSO component from the monsoon, then we can get a beautiful picture of how the other components are playing a role in the predictability of the monsoon, Indians for monsoon. So I want to know that in this season there was no formation of a cyclone over the Indian Ocean. So how this kind of season will play a role in predictability of the monsoon? Sir, can you please comment on this?
Okay, yes, I'll be glad to comment. And I just want to tell you, I have to leave in just a couple of minutes. So this should be the last comment, and after that I'll leave. I just want to thank Tara, thank Bin, thank everybody, all of you guys. It was very, 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 very nice and educational. Let me just first explain what I said. I didn't say anything about predictability. So this is very important to always keep in mind that, are we talking about variability? Are we talking about predictability? So I just said about of course, once we understand variability, we can understand predictability. So what I said is that if you want to explain the variability of the Indian monsoon rainfall, ISMR, famous, for the last 122 years, you see that both Indian Ocean dipole, or some measure, I'm not talking about an index, it's a whole pattern, by the way, that's what we have found, and just same the ENSO pattern, although you can use, when you combine them together and try to correlate with the ISMR in the rainfall, the correlation is 0.8 that we hadn't seen, and we got, as I told you. So in other words, what it really means is that to be able to predict or understand, I will say particularly, the interannual variability of monsoon over a long period of time, we really have to pay attention to both. In any individual year, it will really depend upon how well your model is able to predict both the ENSO and the IOD. Okay, it's very just from the point of view of and by the way, there is a room for a lot of numerical experiments to understand the mechanisms, how with and without IOD, with just ENSO and IOD. It calls for a lot of mechanistic studies. But this is where the challenge is, because on the other hand, if you look at the actual models, and the only thing I have looked at is CFS for 60 years or so with Bohua, Wang, and other. CFS correlation of the ENSO and monsoon over-predicted. Correlation 0.8, 0.7, and much more than observations. IOD 0. So that's one of the challenges in able to do it. But definitely it's a problem worth studying now over a longer term. And oh, one more point. It's not help to take last 30 years of data, last 40 years of data, early 50 years of data. You really have to take the entire data set that you have, for example. Then only you get the actually systematic changes as it is impacted by the global warming. And you just see very clearly how the relationship just gradually evolves. And then you get ultimately a much better correlation. Okay, I don't know, did I answer your question or do you have a follow-up question?
Thanks, sir. That's everything my side. Thank you so much.
Thank you. Thank you very much. And thank everybody. Thank you, Tara. Thank you.
Thank you.
Thank you.
Thank you so much, sir.
Thank you.
And
Thank you.
thank you it has been
Yes.
quite enlightening for all of us to
Tara, this
all of you. And
Yeah.
thank you for in a short notice. Thank you for helping us make this happen. And we would appreciate few points that if you can share, as Dr. Gnanasheelan also mentioned, for the recommendation for the ICTM. So we'll take this forward. All the suggestions. We'll take this forward and make it happen. Thank you.
Tara, one point. One point.
Go ahead.
Yeah. So just one short point. We talked about remote and regional, but
Yes.
also I think the feedback is very important. Feedback between process, local process, and I think that is very important. I think that is I'll mention that maybe.
Absolutely. Yes. And Bill, I will call you sometime and we'll figure it out.
Yeah.
Okay.
Sure.
Yeah.
Sure.
Okay.
Actually, Dr. Gnanasheelan will be organizing one workshop very soon on similar topics, and where we will be inviting students to attend as well. There will be lectures as well. So under the same ICTM. So we can further discuss on various topics that are needed to be covered under this. Yes.
Okay. Thank you.
Hey,
Thank you. Nice meeting you,
Professor
Professor Bin.
You guys can continue. I'll
Yeah.
Okay. Okay, Professor Shukla. Thank you so much.
Okay, Professor Shukla. Bye.
Thank you all. Thank you.
Professor Wang, thank you so much. Thank you. Thank you everyone for attending.
you,
And also
Professor
I want to
Bin.
thank
Thank you, Dr.
Sabine and
Yes,
Dr.
Thank you,
Krishna.
Sabine
Thank
and
you.
Smriti.
Thank you, everyone. Yeah. Bye.
Thank
And
you.
all the people here in the
Good night.
room. Yeah, they were listening. Thank you.
Okay.
Thank you,
Bye.
everyone.
And
Bye.
Bye, everyone. Thanks.
Bharat, who has been helping us with the live streaming and all.
Okay.